Welcome, everybody. Cloud Native Madison, March 2021. Thanks for joining us. It's our 2-year anniversary. We started this in March of 2019, and that feels like about 10 years ago instead of 2, but we're really happy to have been able to keep this going virtually and, looking forward to a future maybe around like the fall time when we can actually all get back together again and add networking back in the mix instead of just talks. But, overall, I'm glad we've been able to keep this community going and we continue to get folks out. We have added a new organizer, Steve Lowry, who's on the call with us today from Integral. He's going to help us out with coordinating this going forward. We want to start off by, as always, thanking our sponsor, Integral. Integral has been our biggest supporter of this meetup from the beginning, always given us a lot of logistical as well as financial support for this meetup. They're continuing to support us through these virtual times via letting us use their enterprise Google Meet account, as well as providing logistical support via their employees. And so we want to give them a big shout out. I'll also mention that Integral is hiring right now. You can find more information about that at integral.com. I think last time I checked, they're hiring both operational folks as well as software engineers. So highly recommend giving them a look if you're in the job market or maybe looking for something new. Usually we take a little bit of time at the beginning of the meetup to go over kind of CNCF news, and in late December, so after our last meetup, they actually released their 2020 annual report with some interesting things in there. So I thought we'd go through that real quick and kind of look at a snapshot of where the Cloud Native Computing Foundation is at. So in 2020, CNCF added 35 new projects to their sandbox, which is kind of their initial entry point of membership for an open source project to join the CNCF. And these projects span the gamut from everything from development frameworks to CI/CD to orchestration to monitoring and operationalizing your application once it's actually out in production. And so it's really great to see just the continued momentum of new projects coming into the CNCF landscape. And then above that sandbox level, we have incubation and graduated projects. And in 2020, we added many projects moving from that sandbox level up to incubation. And then these 5 projects to top all graduated to fully graduated open source projects under the Cloud Native Computing Foundation, which means they validated that the security of these pieces are good. There's ample amounts of community support as well as corporate support for these projects out in the CNCF ecosystem. And so it's great to see, the number of projects just continue to expand, especially as CNCF becomes more of kind of the de facto way to create your applications and run them in the cloud. And so, things at that graduated level are very much enterprise-ready pieces of software, and the sandbox and the incubating levels are kind of on that path to get up to that sort of enterprise-ready, late adopter, software model. So that's great to see that all happening in 2020. Another big thing that CNCF does is that they've been sponsoring security audits for a lot of their projects. And so there was a pilot program in 2020 to support open source security audits for these projects you see up here. Again, a really important step to make these pieces of software that an enterprise can easily adopt and have a lot of confidence that it's been vetted, it has good governance and those sort of things across these projects. And they additionally have plans to scale that project up and provide even more support for doing security audits of these open source projects in 2021. In 2020, I was actually surprised about this, but the end user community, so this is companies that are not necessarily creating cloud native software, but they're creating other software that uses cloud native software as its infrastructure, grew to 145 companies, which actually makes it the largest end user community in any open source foundation. And as you can see here, they've been evolving kind of what it means and how they interact with these end user companies, and the satisfaction rate just continues to climb with this. And so if you work for a company out there that is using cloud native technologies and you're not a member of the end user community yet, I can highly recommend you take a look at that. The pricing is essentially based on how many employees you have at your company, but I'll tell you that it really kind of pays for itself, especially as we look forward to a world where travel and in-person communication is open again. The fees to actually join the end user community generally just pay for themselves in free admission to their yearly conferences, which are always a really good event for the community. Another thing that the funding from these end user companies goes into is a lot of diversity and needs-based scholarships to get more people under this big tent of cloud native computing. So you can see there the number of diversity scholarships as well as need-based scholarships that were granted in 2020. These are typically for things like traveling and expenses for going to conferences. And so, not only is this important just to do the right thing for people who are interested in getting in this space, but it makes our community that much stronger to bring in more diverse points of view and more diverse backgrounds into the community. And so it's just another great way that they're leveraging the investments contributed both from the companies that are making cloud native software as well as the end user companies using that, and how we can support those who want to get into this space. Finally, we have another since December, OPA, which is the subject of today's talk, has also graduated in the CNCF landscape there. So again, that means that it's clear to the organization that they're a good, solid piece of technology. There's a lot of enthusiasm and support around it, and so we're going to see that join that graduated tier of CNCF projects as well. Just a little bit of remaining business then. Our next online meetup will be April 1st. So anybody looking to, come up with your long con April Fool's joke for the meetup, start now. We do have a line on a speaker, actually from our community we're hoping to get in, but we haven't finalized those details yet. So look for that announcement coming up soon, but we will be having a virtual meetup on April 1st. Finally, today's speaker, one of our organizers, Kurt Roekle, is going to be talking about Kubernetes admission controllers and OPA. Kurt comes to us from Styra. We want to thank Styra as well for having Kurt give us a talk today. Styra essentially is bringing enterprise-like features to the open policy agent ecosystem, and I'm sure you'll hear about that a little bit more from Kurt. So with that, please welcome our speaker, Kurt Roekle.
Thank you, Brandon. And yes, I'm happy to be here. And as I switch over to my slides, or actually maybe I should present first, that'd be cool. Yeah, and so I am, obviously people that know me from the meetup here, I have recently switched over to Styra as an organization. And actually, this talk will be more on just OPA itself, more so than the Styra integration with it. So everything that you see within this presentation is all open source OPA, and you can do in the comfort of your own home or your own garage, whatever the case may be. So yeah, so title here, the mission controller in OPA. Yeah, a little background to me again. For those that don't know me well, 20 years of software experience, and like I said, recently joined Styra. Just to be clear, I'm not the foremost expert on OPA, but I do work with many of them, and I can pretty much guarantee that we have others on the call that know more than myself, but I will give you the presentation anyways. So as with any good presentation, let's start with a meme. So, do policy, they say. It'll be easy, they say. So ultimately, OPA is around policy. And that's sort of the theme of what we're talking about here today. And the overall goal is to codify that policy. And today's, where we're going to do that is with that admission controller within Kubernetes. So again, both cloud native projects, and they match up together really nice, as we'll see throughout the presentation. There's many examples within that admission review process of policies that you may want to codify and get within the OPA in order to validate. And so some of those examples may be, just making sure you have images from approved repositories, making sure you have correct labels on things, root privileges, so on and so forth. The other aspect of this is that all of these policies, now they are code. You treat them as code, and bring them into your own source control, have a review process for those, and then apply them to the cluster at the cluster level. Whereas a lot of times we do, if we have our pipelines or whatnot, we might have some of these things set up to do into the pipeline. But what happens when you want to change pipelines? or even update your pipeline version. So this is sort of your catch-all at that point in time within the cluster itself. So in general, what is OPA? OPA is just a general purpose policy engine. It's not tied to Kubernetes in any sort of way. We can use it against all sorts of different needs in terms of what we want to utilize policy for. It makes policy decisions, based on the policies that you'll write, and again, we'll see some of those as we go through there. The input, and that's what comes in to make the decision, and then potentially some other data, and we'll show you each of those as we move through the presentation a little more. Another important thing is it gives you the capability to audit these decisions. So with any good policy, around, you talk about governance in general, you always have, the compliance side of things and verifying and be able to audit, what you're doing in terms of making these decisions. And OPA does give us the capability to audit these decisions as well. It's a very simple REST API. It's JSON in and JSON out. The JSON in is what we call input. The JSON out is what we call a decision. But again, it is just pure JSON. It'll work with that and spit it out. So nothing more than that. So, visually what that looks like is, you have OPA in the center there. And again, the bottom is, on the bottom left there, you have that policy. It's written in a language called Rego. We'll look at that a little more later. There's data with that as well. And then that service on the top, that is, whatever's calling into OPA. We call that the enforcement point. In this case, it's going to be our Kubernetes emission controller, but it can be other things as well, and we'll see that in a second. What OPA is not is very important. It's not a pet, although you may choose to treat it as one. It's up to you, but ultimately, because we're making policy decisions and we want to make policy decisions nice and fast, we're going to have a lot of these running around, especially as we talk. And we won't talk much in this conversation, in this presentation today about it. But another use case for using OPA is authorization around your microservices. And so when you're doing that type of authorization, you want the latency between that to be very small. And so we don't want to have one central one and then having latency going back to that. We want to get these OPAs as close to that decision point as possible. And so generally we're going to have many OPAs. It's also not the source of truth. OPA itself doesn't have, all it uses is memory for storing that data in those policies. It doesn't have any sort of persistent store itself. So generally, the policies ultimately should be sitting in your Git repo. Your data should be coming from other sources, and then there's APIs to push that data into OPA, or OPA can pull out to other places to try to get it. But ultimately, that source of truth is somewhere else. It's not in OPA itself. And like I mentioned already, it's not the enforcement point. Again, it's just bringing JSON in, giving you JSON out, and now it needs that enforcement point to actually do a lot of the dirty work. And so to look at this again with what I just mentioned, right? So that OPA, you might have dozens, if not thousands of these running in your environment, distributed out, closer to those services that are going to utilize them. So again, think of those as cattle, not pets. The policy in the data, we can push it, and we'll show pushing it in today, during our demo. Or in most cases, you'll see the OPA itself pull that policy and data into it and utilize it. And so again, think of that as just being cached from somewhere else. Again, it's not the source of truth. Just think of it as a cache. And then so our service there is that enforcement point. So whatever decision we give back to that service, we expect that service to do something with it. Else, obviously, the policy, doing all this work really does us no good. And some examples of enforcement points, There's really good integrations with Envoy. The application itself can call out to it. A CDI/CD pipeline can do it. And of course, today's example is going to be the Kubernetes admission controller here. But just to sort of reinforce that that last point there with that enforcement point, let's think of it a little different way. So your mob boss makes the decisions. Your assassin does the enforcing of those decisions. The mob boss has all that information to make that, but doesn't really get its hands dirty. So in our case, our mob boss is the OPA, and then our assassin is the Kubernetes admission controller. So another way to think about it. But again, OPA isn't really doing the enforcement and stuff. It needs something else to do that. The other case there is, like I said, we're going to have, you know, dozens, if not thousands of these OPAs around. And generally, you know, you're not going to be wanting to try to manage all of these and push policy and data out to that. But OPA is set up with a set of management APIs to be able to make that a lot easier. And so some of those, when we package up that data in that policy, we call that a bundle. So there's a API there to, you know, for bundles to be able to push bundles into OPA. But then there's this discovery API, and generally, you know, a lot of times that's the only API that you'll actually use. So you'll start up OPA and say, hey, this is your discovery endpoint to go out and discover everything else, and then configure yourself at that point in time. And then there's on the flip side of that, then there's the status. So obviously, I want to know the status of my OPAs that are running out there. And most importantly is the decision log. So there's that API to push those decision logs out. And when you're, you know, want to get into, you know, any sort of compliance type scenario where you need to audit things, those decision logs are very important to take back there. And so those generally, you'll have some sort of control plane that that manages that. And, you know, we'll ultimately have that discovery API so that it can configure all that other, all those other APIs then for OPA itself. And we're not going to get into the control plane here too much today. You know, my company does have a product, you know, for that control plane, Styrad as, but a lot of companies will choose to maybe write their own at that point, or other options or whatnot. But generally, you know, you will want a control plane as part of your overall setup. So again, our assassin for today is that Kubernetes admission controller. I think we're all familiar with Kubernetes. We may not be as familiar with that admission controller and that admission flow that comes through. And more specifically, we're going to be working with the validating admission through the webhook today. There is, and you'll see my next slide, I'll just jump to it. There's two, you know, points to that admission flow that we can hook into generally in the mutating admission and the validating admission. And so if you're not familiar with the admission flow, is it all starts with that API server, and getting to that API request into that into Kubernetes, you'll generally do that. You know, a lot of us are familiar with kubectl, and I'll always say kubectl because I know Brandon doesn't like it when I say kubectl. And then, but ultimately, if you're setting up a production system, you'll probably use something like Helm or Customize to get that in there. But generally, those all are going to be working through the API server. So when that request kicks off, it's going to come into just do the regular RBAC, you know, within Kubernetes authentication authorization. Then it's going to pass along to that mutating admission step. And there is a webhook for that as well, where you can actually change that scope of that object in there. So if you have a pod and you want to place a sidecar into it and do that automatically, the mutating admission is what you'd want to do that, you know, have to do that. And, you know, we see that in a lot of our in our cases for our service meshes. It'll do that sidecar injection. But you can do other things in there too. You could apply labels, resource limits, or whatever at that point in time. Then it goes through object schema validation, making sure that, you know, whatever that that schema of that request is valid. And then it actually gets to the validating admission. And ultimately, that's what we're going to be working with today Once it gets past that, now this is a accept or deny type step at this point in time. So if we deny at this point in time, it's not going to go and get persisted to etcd. If it does make it through here, obviously it will make it in etcd and then be part of the cluster. But this is the step that will stop it at that point in time. So again, OPA can tie into very nicely into both of those webhooks for the emission flow. But we're going to focus on the validating side of it today for our examples. And just to give you a little context of what that looks like. So as you come through that admission review out to the webhook, you're going to get a document that looks like this. Now, this is very much cut down from the actual document, but you can see it's the kind of admission review. And it does tell you under the request, under kind, it tells you what kind of resource that is being requested. In this case here, a pod. It'll tell you the namespace, what sort of operation, update, create, delete type of thing. Some user info around that. But then most importantly, and I have highlighted there, is that object. And I don't have anything in this object, but that object is going to be filled with your manifest that you put for that resource. So if you're putting a deployment, you'll see that whole deployment manifest in here, represented in JSON, obviously, within this. If it's a pod, you'll see that. So those specs will come through in there. In the case of an update, you're going to see the old object as well, which actually gives you an interesting, some interesting things that you could do if you want to make sure that maybe you want to write a rule that you don't want to go back versions, on a particular image. You could do that just using this document here. So we'll look at that a little more. So this is what comes in, and OPA is going to be working with this, and we'll see this in a little bit. And then we want it to spit out, because the webhook respects the response back. Again, it's not a typo here. The kind is still an emission review, but it's much simpler. And this is more or less a full document, although we can put other things on there, messages, when it's denied or whatnot. But really, it's looking for that allowed, whether it's true or false. So, it's a very simple yes or no. You can get into the cluster. You can't get into the cluster type thing. So let's take a look at what these policies actually look like. And we're starting to get into that Rego language, that language behind OPA. So what I have highlighted on top of there is, a very simple rule. In the rule, when you look at these, it takes a little getting used to. Rego is a declarative language. So you're saying what you want things to look like, for your conditions. So I like to think about this as somewhat of a reversed if statement in most of your languages, where that allow equals true is generally what's in the body of your if statement at that point in time. And then within the brackets there are your conditions, are your and conditions. So what I'm saying here is I'm going to navigate that JSON document. So it's going to start with input coming into it. So input request kind equals pod, and input request object metadata labels cost center. I want that to exist. And so those both conditions have to be satisfied. So the sort of pseudocode there underneath of it a little is, again, your if, that's your and condition, then you're going to set allowed to true. Else, if you fail at any one of those conditions through there, it's not going to do anything. Allow is going to be undefined at that point in time. And so that's sort of how you get your or conditions. So if you had an or scenario, so if you wanted, your kind pod and your labels cost center, or you wanted a label of maybe you have a different spelling of cost center, cost plus. I mean, you could do that in one rule, or you could make a second rule saying allow true, request pod and put both of those rules side by side. It's going to evaluate both of those, and either one could allow it. Another important point to note here is that allow equals true. A lot of times you'll see these rules written with just allow there because Rego is going to default to true when something happens in there. It's just part of the language there. So important thing about Rego, like I already mentioned, it is declarative. What you see is sort of, what you're expecting that document to look like. It's designed very well to work with those structured document models like JSON. Like you saw there, it was very easy to navigate down through that. And we'll see it even a little more complex examples there as we get into the demo itself. It's pretty easy to write. There's a little nuances to get your head around being a declarative language, but once you get that, then it's pretty easy to read and write these rules. The other important thing that I already mentioned, it's actual code. So save it in your source code repositories. Go through your PRs, to do your peer reviews on these as you move these through your process. And the other thing, it's a language. It's testable, and there's built-in testing within the language itself, and that's what we'll see here. So that allow rule, now I simplified it a little because I want it to all fit on one slide. And there you'll see that I did change the allow rule to take off the is equals on there as well. So this is our rule, and then we have our test cases are prefixed with test, and we'll see our not allowed. And all we're doing in that test case is we're calling that rule allow, and now we're actually giving it the input at this point in time. So we're saying, using the keyword with input as, and then this is the JSON representative of what we have. So if you look at that JSON document, okay, the input kind is pod, so that's going to pass. Input labels, and then that label of cost center is there, and it does exist. So that's going to pass our test. The second one, we put the not keyword in front of allow because we're expecting this allow to fail. And like I said, it'll treat an undefined just like a false. And so that not will kick off with that. Again, with the input document, and there we left off that cost center label. So that will fail through there, but our test will succeed because we were expecting that deny at that point in time. Okay, so as we're going to start to get into the demo side of things here, and this is essentially what we're going to do. Again, we're going to start with a empty. We're not going to do this locally on Minikube, but if you have a cluster available somewhere else as well, obviously all this will work with that. The things that are highlighted in blue are those new things that we're going to put into this cluster at this point in time. The important aspects of this is, we'll put OPA into its own namespace and throw that in there. All that communication between the API server and the service does have to be over TLS. So we'll add a secret in there to hold our TLS keys, and then create a service for the API server to be able to talk to. In our presentation today, we are going to see one. I'm just going to put one open into there, but ultimately you'd want to scale this a little larger. But as I'm pushing policies into it, you can only push into one at a time. I just don't want to mess with that. If you have that set up with a control plane and it's pulling policy down into it, then obviously scale that to 3 or whatever, so you have redundancy at that point in time. And then that validating webhook configuration is just that configuration that's going to tell the API server, hey, I do have this validating webhook here. And we'll see all of that in our presentation. So, oh, by the way, I will be throwing the slides out on our Meetup channel, or on the event. And I also have a repo here, and that's what you're going to see in the top left here. That I'm going to walk through that, not hit every step here. But I will have that, and I'll publish that repo out there so you can walk through these same examples at home or, like I say, in your garage if you want as well. So first thing here, I do want to acknowledge that a lot of this, what you're going to see here through this demo, a lot of it is there's a good example out on the Open Policy Agent website using the Kubernetes ingress So the OPA ingress tutorial. In the slides, I didn't show it yet, but my last slide is a bunch of references to that. That reference is in there. And also, obviously, the Kubernetes, the Kubernetes site itself, has a lot of information, obviously, on how those all those manifests need to look and everything as well. So used a lot of references, pulled a lot from those. And you'll see that as we go through there. And so I am working with, you do need, some things installed locally, obviously. Cluster setup. I've already set up the cluster, but it is empty at this point in time. And so we can skip all of that fun stuff. So the first thing that we're going to do, like I said, we're going to create a namespace. Our namespace is to put OPA into. And so very simple, create namespace OPA. Again, because we want to create all these certificates and keys, I'm going to skip this. I just so happen to have some of these in my working directory right now, so I don't have to go through the creation of this. And it's really beyond the scope of this talk anyways, but the steps are in here of what you need to do to create those certs. But ultimately, like I said, we're going to put these into a secret, so we can use this within the pod, so we can provide that TLS. So we're going to create that secret. Again, this is going to be in the open namespace. There we go. And then ultimately we want to create that service and deployment. So I'll actually open this up on the left here, if I can find it. Oops. I really wanted you over there. So this is the service. Nothing special about the service itself, just a regular service. The deployment is where we'll see some of the differences. Again, like I said, I'm doing this scaling to 1. Ultimately, in a production environment, you're going to want probably 2 at least, or maybe at least 3 in there. There is this warning that we're putting this up in sort of an open manner, and so you don't. Obviously, when you're going to a production, you want to get this hardened a little more, but for our testing purposes right now, this will be easier for us. So the image is just the image we're pulling off. We are pulling the latest image off of there. We're passing the arguments in to run it as a server, passing in obviously all the TLS certs and everything along with it. The address that it typically opens up is port 8181. And we are going to log in. Hopefully I'll have time to show some logs, pop through here of some of those decisions that come out of that. And then, again, we're mounting the certificates that we created. We're mounting those here so we can use them. And then we're doing the health checks on here. So let's go ahead, and now I lost my spot on this side. That is cool. Right here, so we're going to apply this, and we're going to create that service and that deployment. Those are all good, and we can confirm that. So what we're going to do is we're going to create a port forward here so we can view that. I'm going to start that in a different window here. Okay, so I didn't have a totally clean. I left my old port forward go, which wouldn't work right now, but now this one will work. So we have that port forward, and now I can just check the health of that. And I did do verbose here, so we can see that it is a 200 coming back, and it will just give us an empty JSON document coming back when we know it's healthy. I do have a note in here too. Is you see I am using insecure here. Obviously, this is a secure endpoint here, so curl wouldn't like if you didn't have it there. If you wanted to torture yourself, you could go through. Adding the host entry and passing the cert into curl, so you don't have to use that, but why bother? We're doing this locally. So the next thing we're going to do is the rules themselves. So I'll show you the rules over here. I'm going to start at the bottom. So these are the rules that we're going to put into play today. Again, we're gonna work with the deployment object at this point in time, and so these rules look a little different than what I showed you in an example earlier, but they're still fairly simple to understand. So I have two deny rules here, and ultimately, this first one here is I'm actually using some data. So we're actually going to pump some data into this, and we can see the import of that data here. And I'm aliasing that to Vaughn at this point in time. So what I'm saying here is iterate all through this. So this sum just starts our iteration process within Rego. And so because we can have multiple containers on this manifest, so we're going to iterate through all of these at this point, grabbing off that image, and we're going to check that image against our Vaughn data set here, which I'll show you in a minute, and we're going to grab the number of critical vulnerabilities that we have with that, and we're going to say we don't want anything with criticals greater than 1 coming into the cluster, and so we're going to spit out this message. Just saying that image, has more vulnerabilities than we would like, and then that goes into a deny, ultimately, which will be returned as part of that response back from the webhook. Similar rule on the bottom here, but this one, and this is a very common rule that you may do, is you want something from a trusted registry as far as your containers go. So I'm going to say, hey, this container has to start with my trusted registry, which obviously doesn't exist. But for our purposes here, it's going to work fine. And now any of those containers that don't, also throw some errors for. So the object here is what you'll ultimately will be responding with, an object similar to this. It's, sort of that object that I showed you as part of that admission review step. So we'll say false if there's any reason. So this is sort of the object we want to pass back. So the response equals this object if these conditions are true. So again, it's the same sort of thing here. We're just, instead of, in our examples, we had, allow equals true. Here, we're just giving it a more structured object at that point in time. Again, so both of these have to pass in order to be true. But if one of these would fail, if there are no denies at all, or the reasons are blank, then this is going to fail. So this isn't going to be responded. So then we use this else keyword in here. Else, obviously, we're going to allow this. And so we're going to allow equals true to that. So that's our policy that we're going to make here. And so let's go ahead and apply that. Actually, it won't be an apply so much as we're going to use the REST API into OPA itself and go through that port forward that I showed before. And we're going to push that into it. And again, it gives us an empty JSON back saying that it was okay. If we did have an error in here, it would do syntax checking in here and fail this as you tried to push this into it. The rules, like I said, this one rule goes off of data, this Vaughn, and so this is what that object looks like. It's just a very simple sort of dictionary type structure within JSON with the full image name and version, and just some counts of different vulnerabilities with this. Obviously something I coded with all these vulnerabilities, so it's probably real life. But again, we're going to push that data into this. And if you noticed in the last command, we put the policy to the V1 policies API. The data, we'll put that into the data API for OPA. So now, theoretically, that's all good. And so I do have an example of a manifest, and I keep opening these in the wrong window. We do have a good example here, and so that good example is coming from that trusted repository, and it's the V2. The V1 is the one that they had a lot of critical vulnerabilities, and I keep getting out of place as I do that. So with that, then we have so I have these sample documents here, so we can check these right now against the OPA itself. So we don't have to use the admission webhook to validate these. So what I'll do here is another curl command. And as you can see here, this good document, and you'll see this, this should look familiar here. Now, if I actually pretty that up a little, that'll look very similar to the, from the slides, the example that I gave, that admission review. Again, we have a response true in the UUID that came in, we're passing back with that. So that is a good one. And so we can, this is, and if you notice here that the path that I give here, it goes to data system main. So we check our policies against that data, and system and main, I will call those out a little. So that is our package in our rule. And so our package up here we saw was system, and then our rule that we're trying to do is main. Interesting enough, we could, if we wanted to, look at this whole document and have it evaluate everything in the document. And there, again, we'll see our result in here, which we saw before, or in the response. But all these intermediate rules will be evaluated on their own as well. Typically, we're going to evaluate down to a rule level at that point in time. So I also have some bad documents, and we can look at a couple of those right now. And again, I'll pretty these up. Or I won't. Oh, I did that last night as I was going through this as well. Now I do this. So here's our denial at this point in time. So again, we have our allow equals false, but now we do pass back that status with the actual reason. And as you saw from the rules before, we were putting that image name into there. And if you have two denials, the way we wrote the rules up there is if we had a case with both denying, we'll see both of those reasons in here. So we put it in comma separated. When we concatenate here, we put a comma space in between those denies, and that's what we see here in the reason when both of these are denied. So we seem to have a OPA that's happy and will take some these requests, and it seems to be doing what we want to do. So now it's time to fire the missiles here. So now it's that validating webhook configuration, that switch that's going to turn on, connect the API server and the admission validating webhook to OPA. And so that document looks like this. We give it a name or whatnot. We tell it, what admission review versions that this webhook works with, if there's any side effects. But important things here are some namespace selectors here. So we have something that we can label namespaces with to ignore policy for that. This is sort of that ultimate case of do as I say, not as I do, because we're going to turn off the policy validation for OPA and actually kube system as well. And the reason for that is if you have a rule in there that will affect the starting up of a pod, because pods come and go all the time, right? So you do a node upgrade or whatnot, all your pods are going to be blown away, come back. If you have a rule in there that doesn't start it back up, now none of your policies are going to evaluate at that point in time because you have no OPAs to go. So generally, and it is recommended by Kubernetes to turn it off on your namespace that you're doing, you're executing your policies from. Along with that kube system. We can give it operations here. A lot of times, if you're setting up a general webhook that you just want to do everything with, a lot of times you'll just star all of these as far as operations, API groups, versions, resources, and whatnot. Star them also. All of these come through here. But if you're making a webhook that has a very specific use case, you can narrow these down. So I threw that in there just to show that you can do it. Obviously, we do need that CA root cert as part of this, and so that's why I can't, into my repo, I have all these examples, but I don't have this one checked in, but you can generate this one with this command. Again, I just so happen to have one of these sitting in my workspace here, so I will apply that. If I remembered what I called my KA is just a alias off to the Kubernetes apply, taken in a file. So hey, that went easy. We have an emission, validating emission webhook going. So like I said, we do want to throw these. In fact, I did this out of order because I wanted to apply these first. So this is the one for the kube system, to throw that label on there. And well, okay, so I had that one on there from last night. I didn't remove it. Sorry about that. But this one needs to be labeled as well. So we're going to ignore that for these. This is one we really want to do the apply. We'll see how broke I made things. It shouldn't do anything at this point in time. So now let's test some of this out. So we have some tests here, and so let's look at this. Crit one is the the vulnerability one that again is going against that data set or whatnot, and I will show you that over here. So again, this is just that trusted API, simple manifest. So if we do that one, now we're going to get an error here. So just through kubectl here, we can see that it gives us our message out here. We deny the request, and this is our message that we sent out of here. We're saying that this has 10 vulnerabilities, so we're not going to let this into the system. So same sort of thing with the untrusted one. Again, we're saying this is an untrusted repo that this is coming from. And of course, it's denying that the same way. So we get that message out of here as well. So that is working. And obviously, we can apply a good one here. And this one will get applied into it, although it'll never start up because it's not an actual repo. But you can see it is sitting in there, and obviously it can't pull the image. But it made it into etcd. You know that because we're looking at it right here. So that is an interesting, it's pretty simple to get that set up in a very basic way. One of the other things I do want to show you, since we do have, we're still running pretty good on time. I'm surprising myself with that. So let's look at the OPA logs for a second. So get our OPA here. So now a lot of logs, these are statuses that it's sending back and forth. But if we scroll up enough here, so there's a lot of statuses to come through. If we scroll up enough here, hey, look at this. We get to the document. And so there is a nice long document here that has everything. But I do have a better example of that over here somewhere that will be a little easier to read. So this is what it looks like in the log itself. So you see that input document. Again, this is the input that's coming into OPA at that point in time. It is that emission review. And like I said, when I gave the example before, there is a lot of information that comes through here. But we can see that we have our kind of deployment. It's kind when you navigate it through. The name of it, the namespace that it's going into. But then we have our object. And so this is where I said, so this is, oops, I don't know what I hit, but we'll deal with it. So this is I must have deleted something or formatted. This is our deployment manifest. So we can look at through this, and it looks, pretty much like what we would expect here. We'll collapse the managed fields there for a second, but we'll see our spec, we'll see our replicas of one. We'll see our template down here. We'll see our image. So this is what that document looks like as you come in. And I did happen, even though we created a new one. This example here I pulled with an old one. So you can see this old document object filled out here as well. And again, it's what was an etcd, or I should say what is an etcd at the time that you evaluate this rule, and the object is what you want to apply to it. So you could compare these back and forth again, like I said. Another interesting use case, if going along with that critical vulnerabilities ones, maybe you have, you're trying to make an overall effort into your system to reduce vulnerabilities, in your in your overall cluster. And, obviously it would be kind of difficult to say, hey, we're just going to drop dead, not, allow anything into it. But you could, off of this object and the old object, you could write a rule that say, hey, I want to reduce, by 10% anything that you put into the cluster. So if the vulnerabilities aren't reduced by 10%, then I'm going to fail it. So you could, off that old object, you could check that database of vulnerabilities. In the new object, you could compare that, do the math. You could check that at your admission review. So another use case that you could do off of that, but there's, you can come up with hundreds of different use cases for that. Just a couple of closing points here. Again, remember this is an admission webhook. So this is gonna, when things happen, when state changes within the cluster is when this is gonna happen. So when we apply this webhook, and if there's something running in the cluster, nothing's gonna happen to that stuff that's running into the cluster. What's in the cluster is in the cluster only at the time of admission. But again, that admission does happen with cluster changes, whether they're scaling changes or other things within the system. It'll run through the admission webhook at that time as well. So it will happen to those scaling things. So if you have something in there and that pod goes away, and then you scale or do a node update and kill all those pods, it's going to run through this and check it. You might not be able to, they might not be able to start up after that. So be aware of that as you start your journey into this. The other interesting thing of, maybe this is just me, but when we use deployment a lot, and a lot of times we don't think about that, behind the deployment there's pods and replica sets. And so if we start writing rules against pods, which is, we'll probably see a lot of those types of rules, but when we do that, if we don't match that rule with a deployment, the pod will fail, but it won't fail through our kubectl, right? So our kubectl, when we apply the deployment, is going to succeed because there's no rule written against it. But then as the API server, takes that deployment and expands it out to the pods and replica sets, when it tries to create that new pod, it's going to go through that admission review, and it's going to fail at that time. So you can get your cluster into this weird state where the deployment says that this is, the template of the pods, but the pod says, nah, I couldn't change, so this is what I am right now. So you can get into a little weird state. So just be aware of that as you're writing some of these admission controllers. And again, I've said it a few times throughout the presentation, but this is a very simple example. There's hardening that you want to do to go into a production environment to do this sort of setup for the admission. Obviously we want to scale and then harden those endpoints, so you can't just push rules and data in just anybody like I did here through the command line. Oh, I forgot to put my nice little, that's me pushing policy data into it. Google Slides doesn't have like an actor icon, so I sort of had to build one there. I was very proud of that. I can't believe I missed that. So again, I do have all these references. I will post, again, both these slides in the that Git repo that I have. I'll post that out on the meetup site. And with that, if there's any questions, I have no idea what window my Google Meet is in, but any questions, I'm happy to field them.
Yeah, thanks, Kurt. I definitely have a couple of questions, but want to make sure the community also has a chance. So, there's this raise hand button in the lower left. If you want to go ahead and ask a question, I'll go ahead and get us started though. So, one thing that jumps to mind with your demo there is wondering whether there's a way, sort of before you actually get to that kube control apply step, not kube cuddle, whether you can actually kind of validate your manifests are going to work, right? So, I can imagine a pipeline where, you build your image, you generate your Kubernetes manifest, and maybe at that point, before trying to do your kube control apply, is there an easy way you can kind of like run that against the known policies before you actually try to submit it, so you can kind of like shift left where you're failing the pipeline?
Yeah, so there's definitely, and I didn't mention, but OPA does have a nice command line along with it as well. So you can, if you have those access to those policies in the data, you can run that locally. And there are other ways to, especially when you're using like a control plane or whatnot, there's ways to post against that. And like you saw, in the demo, you can check against those running OPAs, if you open up, some way to get at that and to be able to run those.
Cool.
But yeah, it is common to check those ahead of time as well.
Mm-hmm. Cool. Go ahead, Steve.
Yeah, so what are you mentioned the data and the policies, not the source of truth, so you kind of consider it a cache. What are the options for persisting that data so that you're not losing losing that data between, a cluster upgrade and your OPA server gets restarted? You don't want to lose all your policies. So I assume it handles volume mounts, or like, what are the options there?
Yeah, so that's where that control plane comes into place. And, all those management APIs that I showed in the one slide is ultimately you want that management plane, and it's generally not going to be the source of truth for that information as well, but it's something that exists there that will then, be that cache for that other cache to be able to distribute that back down. So how it generally works is that control plane, has that discovery URL that the OPA knows about. And so it goes back to the control plane and says, okay, give me all this information. Where do I need to get all of this, these APIs for other things? And then the OPA will check it's configurable, but I think by default between every 10 and 15 seconds, go back and check for new data with that. So when these OPAs stop and start, all they really need is that discovery API to go back and then to get that data in policy from somewhere else to pull into it. And like I said, it'll check that every 10 to 15 seconds as it's running.
Cool. We got Dennis next.
A couple of questions. How easy is it to implement OPA on an existing setup? Obviously, with your magic, it was fairly easy to implement on a new cluster, right? But on an existing, well-developed cluster, what are the challenges?
Yeah, so the setup and getting it running is essentially the same steps that I went through right now, but it does go sort of with one of those last points that I was trying to highlight is as you start writing rules into an existing running cluster, that's when you get your actual state of the cluster disconnected from the actual rules. And so if you do have any events that restart things within the cluster, you can get your cluster into a bad state. So as you apply this to a running cluster, yeah, you do want to be aware of that. And ultimately, you want to try to get all of your resources pushed again into the cluster and get them through those rules, to get it going. But again, that can happen at any point in time, even not during when you just start. Whenever you change a rule, you could be in that same case. So it's something to always be aware, as you go through, just to make sure, because it's definitely, as you're changing that, you could get your cluster into a state where it's not going to work how you expect it.
Thank you.
But the other point there is you'll always, those decisions, you'll have an audit trail for those decisions. And that's where I say, the OPA also sends those decisions back to a central location. Ultimately, you should have that in a place where you can view those things. And so now you could see and I didn't jump into it enough, but you can see that decision. You can see, sort of what rule triggered that decision at that point in time. So if things aren't, restarting as the way you would expect, you'd go back to that decision log, sort of look at that. Oh, this is the rule that's sort of stopping that, and you could maybe do something to bypass that rule initially to get that going again, or again, change that resource to something that's valid through the emission review.
Sure. Thank you.
Yep.
All right. Not seeing any other raised hands.
Last question. A use case for, you said you could also do it with mutating webhooks. Like, what would be a use case for using OPA with a mutating webhook? Like,
well, it's just to do that mutation, right? So you might even have a rule that says that you have to apply certain labels. The example we like to use a lot is like that cost center label, right? You have to have that cost center label on there, and you'd have a validating validating rule that would do that. But you might also have a mutating rule that actually applies that. So if you're saying, hey, it's missing there, I know it's from this namespace, and again, I can use some data or just sort of have a rule written saying, hey, just automatically apply this label to it so it makes it through that validation at that point in time. Also, another common pattern is the sidecars, to throw a sidecar on there for other things. And again, you could do that by namespace or whatever. So yeah, there's a lot of things that you can do with that at that point in time. But resource limits is another good example of that, right? You want to make sure all your resources have resource limits, so you can put those on with a mutating as well as a default.
All right, awesome. Well, if no other questions, we want to thank Kurt a lot, and thank Integral and Styra for contributing to today's meetup, and everybody for coming out. Thanks a lot, and we hope to see you next month.